Schools in a certain state receive funding based on the number of students who attend the school. To determine the number of students who attend a school, one school day is selected at random and the number of students in attendance that day is counted and used for funding purposes. The daily number of absences at High School A in the state is approximately normal distributed, with mean of 120 students and a standard deviation of 10.5 students. A. If more than 140 students are absent on the day the attendance count is taken for funding purposes, the school will lose some of its state funding in the subsequent year. Approximately, what is the probability that High School A will lose some state funding? To answer this question, let the variable x represent the number of students absent on a given day. The mean is going to be 120 students, the standard deviation 10.5 students, and we are going to determine the probability that the variable x is more than 140. Because the absences distribution is approximately normal, it's possible to use the normal distribution C-score to calculate the probability of x more than 140. Using the C-score formula, plug in the values for mean, standard deviation, and 140 for x, we find the approximate value for the C-score of 1.905. Then, the probability to have more than 140 students absent is the same as the probability to get the C-score more than 1.905, or because the symmetry properties of the normal distribution, the probability to get a z less than negative 1.905. To compute these probabilities, we can use a table or a calculator. With any of these two items, we can find that the probability is going to be 0.02839. We may then conclude that the probability that this school loses state funding because the number of students absent is greater than 140 is approximately 2.84%. B. The Principals Association in the state suggests that instead of choosing one day at random, the state should choose 3 days at random. With this suggested plan, High School A would lose some of its state funding in the subsequent year if the mean number of students absent for the 3 days is greater than 140. Would High School A be more likely, less likely, or equally likely to lose funding using the suggested plan compared to the plan described in Part A? Justify your choice. To answer this question, let the variable x bar represent the average number of students absent in 3 days, and n the sample size or number of days attendance is taken. The mean is again 120, the standard deviation is 10.5, n equals 3, and the probability of x bar more than 140 has to be calculated. Because this problem involves now a sampling distribution, the C-score associated to the above number is now different. Plug in the corresponding values. The C-score is now 3.2991. Then, the probability to get an average number of students absent in 3 days greater than 140 is the same as the probability to get a C-score greater than 3.2991, or the probability to get a C-score less than negative 3.2991. Using a table or a calculator, we find that the probability of C less than negative 3.2991 is 0.000485. In conclusion, the probability that this school may lose state funding because the average number of students absent during 3 random days be greater than 140 is about 0.05%. It's less likely that the school loses state funding if attendance is taken during 3 random days. The greater the number of random days, the more unlikely to have a high number of bad attendance days to give an average greater than 140. To understand better the previous conclusion, let's compare the graph when taking attendance 1 day and the graph when taking attendance 3 days. The standard deviation of the sampling distribution for the 3 days is less than the standard deviation of the single day distribution. So, the value x equals 140 is more standard deviations away from the mean in the 3-day sampling distribution, what means that it's more likely to have a single 140 absence day than 3 low attendance days averaging 140. A typical school week consists of the days Monday, Tuesday, Wednesday, Thursday, and Friday. The principal at High School A believes that the number of absences tends to be greater on Mondays and Fridays, and there is a concern that the school will lose state funding if the attendance count occurs on a Monday or Friday. If one school day is chosen at random from each of 3 typical school weeks, what is the probability that none of the 3 days chosen is a Tuesday, Wednesday, or Thursday? Let's represent graphically the school week with the critical days in red. The probability that none of the 3 days chosen is a Tuesday, Wednesday, or Thursday is the same as the probability to select a Monday or Friday from the 5 days week. In this case, the probability to select a Monday or Friday is 2 out of 5 or 0.4. The probability to choose in all 3 weeks Monday or Friday can be computed with the product rule for independent events. And in this case, the product of these 3 probabilities is going to be 0.064. Then, the probability that none of these 3 days chosen is a Tuesday, Wednesday, or Thursday is about 6.4%. In conclusion, it is not very likely that High School A loses state funding if attendance is taken during 3 different days.